All right, welcome back to part 4 of the code signal arcade series. And then let's just go to the problem, shall we? And this is problem number 34. It's called extract each kth, I guess. All right, so what does it mean? Given an array of integers, remove each kth element from it. Okay. So I guess if it's 3, then this is removed, and that is removed. Okay, gotcha. So I think the optimal way of doing it would be just have a new array, and then we can loop through the number and the index together, enumerate input array, and then if index is divisible by, I think index plus 1 is divisible by k, so I think there should be a parentheses here equals 0, then okay, so if it's not, I guess, okay, so if it's not divisible by, then we want to append the number, right? So that's how you skip the numbers and then just return the array. Let's just check that. Okay, cool. So the time and space complexity of this would be just O of n, right? Both of them, because we're creating a new array and then we're just looping through everything. So that's that. Okay, let's go next. First digit, okay. Find the leftmost digit that occurs in the given string. Okay, cool. So it's just digit, right? So, okay, it's not even a number. Gotcha. All right, so we can just loop through on each of the input string. And then there's a neat function called isDigit on Python. So return C. Then return, I guess, empty. I think there's a guaranteed solution, right? So let's just check that. Okay, yeah. And the time and space complexity would be, space is so fun because we didn't declare any new variables, and space complexity, time complexity would be O of n because we're looping through every string, right? So let's go to the next question. Given a string, find the number of different characters in it. Okay, so this is like a classic set problem. So you can just actually do it with one line in here. So set of s would give you a set that contains every character's in the string, right? But definition of set is that you don't have different elements, right? You just have unique elements. So essentially what it means is it will have only the different characters within the set. So, and then you can just return the length of the set, and then that will give you the answer. So yeah, that's about it. So without set, this can be a bit problematic. I mean, you can still solve it, but having a set is like a really awesome way of solving this kind of problem. So I would really suggest learning about sets. Great. Okay. Oh yeah, on the previous problem, the space complexity is constant because there can be maximum of 26 characters, right? And time complexity is O of n because we're gonna be looping through the string in order to create the set. So yeah, that's that. All right, on this problem, given an array of integers, find the maximal possible sum of its k consecutive elements, okay? So k is given, and then I guess if it's 2, then this is the answer. Yeah, I'm not sure if there is a optimal solution to this. Well, I guess there is. Okay, so I guess the idea is just first find the sum of the first k, and then while looping through it, you add the right one and then minus the left one, and then just keep comparing it to the sum, basically. So I think that's what I'm going to do. So s is equal to sum of input array until k, right? So that's going to be our first benchmark of the sum. And then the range would go from 1 because this is already counting the 0th one, right? So it's going to go from 1 until length of input array minus k, all right? So then the sum would be maximum of input array. Oh, no, wait. Maximum of s plus input array plus, I guess I have to update the sum again. Okay, gotcha. So there should be like two variables to keep track. So S is like the running sum, right? So the running sum, and then maximum S is like the maximum sum. So the running sum, it should be S plus plus input array of I plus k. All right, and then minus input array of I minus 1. So I'm subtracting the previous one. Okay, so that's that. We are going to update the S, and then we're going to update the maximum if there is necessary. Maximum S and S. Okay, and then return maximum S. So let's just try that. Oh, it didn't work. Return value 7, 8. I think there's like a one-off error in somewhere. Okay, so maximum is first off 5. Now let's just print the maximum S in here and see what happens. 5 and 7. Okay. 5 and 7. Maybe there's like I is... Okay, so first off, the K is 2, then I is 1. So 1 plus 2 is 3. 0, 1, 2, 3. Okay, so we are going to be... So this is 5 is the first S, and then we're going to be using this one, right? So essentially that one is subtract 2, which is that, correct? And then plus K. Wait, I think this plus K is wrong, actually. This is 1. I think there should be minus 1 in here. Let's just check that. Oh, nope. Because the first of 2 passed. Oh, I think this one is actually... So every test passed except 1. Okay, so let's just check this test. K is 3, so return value is 6. It should be 9. Oh, I think there should be plus 1 in here then. Okay, gotcha. So there was just edge case that it didn't account for, and this one should be minus 1 to account for the plus kth, right? So that's that. Great. Okay, so on this problem, the trick is to have a running sum and also the maximum sum, like 2 variables to keep track of, and then just do that. And the space and time complexity of this would be space is constant, right? We didn't declare any new variable, and the time complexity would be O of n because we're just doing one loop, right? So that's that. All right, so the first island diving deeper is done, and then let's go to the dark wilderness then. All right. Oh, I think I remember this problem actually. Yeah, so essentially what happens is there's like a tree, right? A plant. And during the day, it grows by like up speed, which, that's 100, right? And then during the night, it goes down in height, and then there's like a down speed of 10, right? So which means on the first night, or first day, it will be 100, but on the first night, it will go down to 90. And then your desired height is the third argument, which, I guess it's 910. Then it's just saying, hey, how many days would it take to reach 910, right? So that's the problem. And then the easier way to solve this would be a simulation, right? So that's going to be the easiest, but I think there's also like a mathematical way of solving it too. So let's do the simulation first, I guess. I think that's pretty easy. So day is, I guess they start from 0, right? So while 8 height is the current height, while height is less than desired height, day equals 1, increase it by 1, and then essentially like height plus equals up speed. But I don't want to subtract it immediately though. How should I do this? So essentially, like whenever there's like up speed, I want to check if height is greater than desired height, right? Then return day. So I want that, and then height is equal to. I guess we can just do true then, because eventually it will go to this one, right? So we can do that. Height down speed. Okay. Turn 0, I guess. So we can do this and then it will work out. So this is like a simulation, right? But it's not a really good solution, I would say, because you can just do some math in order to solve this problem. But there is like a tricky way of doing it, right? So essentially, the diff, right? So each night, the plant grows by 90, right? So if you can subtract like 100 minus 10, it will be 90, and then you can basically like each night it grows by 90, and then it reaches here, and then during the day it grows here, and then boom, you're at the target, right? So you have to account for the last night, essentially. So that's kind of the tricky part. So if you just do something like return up speed minus down speed, and then that's like the rate, right, per day, growth per day, and then if you just do this desired height divided by like, it's not going to give you the correct answer because you didn't account for the last night's growth, I guess, the last day's growth. So that's why it's going to be like one off essentially. I mean, it's in certain cases it may be like even 2-3 days off, depending on the diff, right? So that's like one caveat. So I'm not sure how to clearly account for that. I think there is a good way to do it. Let's see. So I don't think this is necessary, but essentially like if up speed is greater or equal than desired height, then just return 1, right? So it's just on the day 1 just got it will outgrow. The night doesn't matter, right? So if up speed is desired, then it's just going to be 1. So that's like the best base case. And I think what we can do is, okay, so desired height is 910, subtract day, that's 810. I guess what I can do is desired height minus the up speed. So if we do this, then we're going to be eliminating the last day's growth, right? And then do this. So that's going to be how many days? And then plus 1, I guess. Okay, let's just try that. Okay, didn't. I mean, it almost worked out. Okay, so let's try this one. Desired height is 7. Okay. Return value, your value is 1. Okay. So what's wrong here? So the up speed is 5, down speed is 2. So at first night it will be 3. Second night it's just gonna be greater than that, right? Okay. Desired height is 7 minus up speed is 2. Okay. And then 2 divided by 3. I guess I should do this and then math.ceil, then math.ceil. Let's try that. Okay, there we go. Cool. So let's just try if this is gonna be necessary. Okay, I guess I have to take this into account. Okay, whatever. Okay, this is the optimal solution essentially. So the time and space complexity would be just constant, right? 0, 1. So yeah, this is the math. Essentially, the trick is to remove the last day's growth and then do the calculation, and that's going to be it. And then add 1 at the end, right? Because you removed the day growth, and then they have to add it back. So that's that. Cool. Let's just submit this, and then it just keeps annoying coming up, right? So Knapsack Light. Okay, you found 2 items in a treasure chest. The first item weighs weight 1 and then it's worth value 1. And the second item weighs weight 2 with worth value 2, whereas the total maximum value of the items that you can take with you, assuming that your max weight capacity is max weight. And you can't come back for items later, okay? There are 2 items. So I think there's just like a few possible scenarios, right? So if weight 1 plus weight 2 is less or equal than max W, then you basically get everything, right? If you can get everything, then just get everything. So value 1 plus value 2, right? So now there's going to be a choice, right? If you can't get both of them, then what are you going to do, right? So is there going to be a case where there's just 0? You can't carry anything? I guess there should be, right? Can't take both items. You can't take both items with you. You can only take the first item. Yeah. Note that there are only 2 items. You can bring more than 1 item each type. Yeah, you can take 2 the first item. Yeah, that's correct. Yeah, I guess there can be a case. So if weight 1 is greater than max W and weight 2 is greater than max W, then it's just basically you can't get anything, right? So it's just return 2. And then if that's not the case, then just return essentially like one of the weights is going to be less or equal than that, right? So you can get just the maximum value item. So value 1 or value 2. That's it. You can't get anything else. Oops, there was one test case it missed, I guess. Okay, so what is this? Value 2. Oh, yeah, I guess this is wrong then. Okay, makes sense. Okay, so if both of them are less than that, I guess. Okay, so let's just do 1. There should be like a really better way of doing this, but let's just do that. Max W and weight 2 is less than max W, then return the maximum, right? So if you can take both of them or the other, then just return the maximum value item. Then if weight 1 is less than max W, then return value 1, then return the value 2 essentially. So I think this should do the trick. Or will you not? Okay, this is so weird. Why is this not working? Return value. So I'm returning 20, which is that. Weight 3. Weight 2. I guess it should be like this then. Yeah. Okay, yeah, there we go. Yeah, so if you can carry them, right, then you just take it. Okay, yeah, this should be it. So this is actually like there's a problem called like 0-1 knapsack, right? But that is like it's essentially like you have many items. This one it has like only 2 items, right? But that problem has like many items, and then that's actually like a really hard problem to solve. So you do like dynamic programming to solve that. But in this case, like, we can just do this kind of like if else statements, and this is pretty much it. Because I think Knapsack Light is just trying to introduce the knapsack problem in general, right? So I think I don't see a bad approach in here. You have to do some sort of if else in here, because like there's just so many things that you can consider, right? You can either return this or 0 or the maximum of the 2, or just either or, right? So I'm sure that you can, like combine some of the if statements, but I mean, this is good enough, I would say. So we can just go to the next question. Given a string output, its longest prefix, which contains only digits, okay? Yeah, that makes sense. So essentially you have a string, and then return the digit prefix as long as it can, right? So what I can do is for ci, c in number, right? So we want to loop through the string with index and the character. So, and then if c is digit, then you can keep on going, right? Okay, I guess we can just do if not c is digit, then break, right? And then s would be like empty string, and then you can just do like s is equal to input string. I guess what I can do is like store like an index variable here, and then index would be I, and then return input string of index, like that. So you just have like an index, and then whenever c is not a digit, you mark it, save it, right? And then just break it out of it. And then I think this should just work. Oh, wait, what? Oh, everything is... let me think. So if it didn't reach this, then it's everything, right? So how should I go with that? I guess I can... Length of input string is going to be the default value then. Yeah, okay, gotcha. So yeah, that was a trick. So basically like the index would be assuming like everything is digit, right? And then just do that at the end. So the space complexity of this would be, I guess oven technically, because we're going to copy it if there is like everything is digit, right? But even if it's not everything, then, you know, it's still going to be of one, of n. I mean, if it's like last character is a character, not a digit, then we're still going to copy everything except the last one, right? So that's that. And then the time complexity would be O of n, which is because we're looping through everything, right? So, okay, let's go with the next one. Let's define digit degree of some positive integers as the number of times we need to replace this number with some of its digits until we get into one digit number, okay? Given an integer, find its digit degree. Okay, gotcha. It's an interesting problem. So with these kinds of simulation type stuff, right? And you don't know when to stop, right? A while loop is going to be the perfect solution here. So essentially, like if your n is greater than 10, greater than 9, I guess, because it's a 2-digit number, right? Then, which means you have to keep on looping. And then degree would be start with 0 and then 1. And then basically just calculate some digits, right? Update the n. So, and then you can create like a helper function to do the sum digits. You don't need to, but I like to have that number. And then s is equal to 0 while number is greater than 0. And then you just basically add number, the last digits, and then you update the number by decreasing it by 10. And then return s. So that's going to be your sum digits function. And then return degree. I think that should work. Okay, that's about it. And the space complexity is obviously constant, right? Because we're not storing anything extra. And the time complexity would be, it's hard to tell actually. What is? I guess it's kind of constant in a way because maximum number is like limited by 10 to the 9, right? And then this is just gonna run like maximum 9 times for digit calculation, and the sum would be drastically different, right? So I think it's just both of them are constant. So there we go. Okay. Is that the last one then? Okay, let's go to the next question. Okay, cool. So what does this say? Given the positions of white bishop and black pawn, okay, on the standard chessboard, determine whether the bishop can capture the pawn in one move. The bishop has no restrictions in the distance for each move, but is limited to diagonal movements. Okay, yeah, okay. So essentially you have a chessboard, and then you have the location of the bishop, and then location of the pawn, and then just, you know, whether or not you have to show whether or not you can eat it or not, essentially. So, okay. cool. Yeah, if you know chess, then it's going to be really, really straightforward to understand. But if you don't know chess, essentially, bishop is a piece that can move diagonally, and that's it. That's the restriction. And then, so in this picture, you can eat it. In this picture, there's no pawn. So, but in this picture, you cannot eat it because no, you cannot move like up or down, right? You can only move diagonally. So that's why. So I guess the one way to solve it would be just mark every nodes that you can, like, I mean, every cell that you can eat, just mark them. And then make sure the pawn is on those or not. Just check that. And then that's it. I think that's going to be like the easiest approach, I would say. Yeah, let's just do that. So in order to do that, I think we should convert these cell like locations into numbers. I think that's going to be the easiest because it's like really convenient to move up or down with numbers, right, instead of letters. So essentially, like bx would be your bishop x coordinate of the bishop. Then that would be like bishop of 0, which is, you know, a number. I mean, a letter, right? So I think you can convert that letter into like an ASCII character and then ORD of small a, and then that's just going to give you like the index of the a, right? So if it's a, then it's 0, then if it's b, it's like 1, blah blah blah. So and then you can add 1 to it, so that will kind of give you like a location 1 1 2 2 3 3 blah blah. And then the by, the y coordinate of that is just simply the bishop of 1, and then we have to convert it into the integer. Yeah. So I think it may be beneficial to reduce it to 0-based index, but right now it's like 1-based index, right? I mean, it's your call, but let's just keep the 1-based index and then see if it makes sense. Okay, so let's do the same thing with the pawns. So px, py, bishop, pawn, pawn. Okay, so that's how we convert the coordinates into numbers. Okay, and then basically you have let's just do like a set of moves, right? Like cells would be set, empty set at first, because okay, so these sets cells would be indicative of, you know, which cells that I can capture essentially. So a bishop can move into 4 diagonal terms, right? So let's open like moves, then directions, right? It can go to 1 by 1, like up or down, and then it can go like -1 or 1, and then it can move 1 -1, and then, or it can move -1 -1. Like these are the 4 diagonal directions, right? By x and y. So we can do like dx, dy, which is, you know, indicative of like delta x, delta y, which is like a difference of, right? I mean, these numbers doesn't really matter, but we could just use that. Okay, so these are the 4 directions that I can move, and then just loop through, and then keep on going until we hit like a border, edge border, right? So while the current x, current y is equal to bx plus dx, and then by plus dy. So this is going to be our like next move, I guess. So you just basically keep on moving it like that, and then until it hits like the edge of the border, then you stop, right? So, and then the restrictions are you have to be greater than 0. That's the restriction of x, and then you have to be less than 9, and 0 per y less than 9. Okay, so these are like the restrictions on, to hit the border. You have to inside the border. Okay, and then if it is, then essentially you just add it to the cells, and I think it's better to just add it as a tuple, because you cannot add a list, right, to a set. You have to add like a tuple, which makes it immutable, so which is pretty nice. Okay, cool. But is this now correct though? I have to keep on updating. Let me see. Okay, so the current is that. So I increase added by 1, then it keeps on adding it until the limit is reached. I think this is fine, okay? And then essentially now we have all the cells that it can eat, that can capture, and then we can just check essentially like if px, py is inside the cells. If it is, then you return true. If it's not, then return false. Okay, let's do that. I think it just made like an infinite loop kind of thing. Dx, dy, 1, 1. I'm not sure why it did infinite loops. Px, py, px, py. Let's print out the cur x, cur y, and see if I can see the output. Okay, it just goes on 2, 2, 2, 2, 2. Which I don't know why though. It should be increased by dx and dy. So directions. Print dx dy. Okay, so it goes 1, 1, right? And then, oh, right, it's adding px, not, okay, so this is wrong. So you have to add cur x, cur y. Yeah, okay. Now it should work. So you should be updating the current one, right? Not the original one. So, okay, cool. There it is. All right, now we have completed the problem. So in here, I don't think there's much to say about the time and space complexity. The chessboard is limited, right? It's like 64 cells. So we can just say constant because like the cells can be maximum of like what? This probably is the maximum, which is 6, 7, which is 13, right? So we can be like large as 13 and that's it. So, and also like we're checking this one which is constant. So we can say like these are constant space and time complexity because it's not going to be like infinite, right? So that's that. Okay, so this is like one of the solutions, but I'm pretty sure there's like a really good mathematical solution too, which I'm not really sure about. Let me think. So it might be like a number theory problem kind of thing too. So 1, 1, 1, 1, 2, 2, 2, 2. Yeah, there can be like a really good number theory solution besides this thing. You just basically like do some invariants, but which I'm not really sure if it's efficient or not. But it may be, it might as well be. But we'll see. I mean, yeah, I think this is a good solution though. We'll just move on. All right, cool. Let's just move on to this. So hopefully we can finish it within the hour. We have 5 problems, so let's go. Is beautiful string. The string is said to be beautiful if each letter in the string appears at most as many times as the previous letter in the alphabet within the string. What? Okay, B occurs more than A. Okay, C occurs. Okay. Note that letter A has no previous letter. Okay, given the string, check if it's beautiful. Okay, the output is true because it contains A 3 times B, C, D. Okay, so basically, essentially, it has to be like descending order, right? And when you go from A to Z, it has to be like descending order, I guess. So that's the idea. So essentially, you just count every letter in the string and then sort it by like A, B, C, and then it has to be on descending order. So that's the beautiful string definition. Okay, so let's just try that. then I think it's good to solve this problem using like a bucket system, right? So you just have the 26 zeros, and then you just count number of A's, number of B's according to the index. So A would be the 0th index, B would be the first index. Not the first, I mean, I guess it's the first index. All right, so let's just do that. For C in input string, chars of ORD of C minus ORD of A, and then plus equals 1. Okay, so now this will be counting every character in here. So that's that, and then we just move on to the list one by one, right? So we can do starting from 1 and then until length. That's just not length, let's just say 26. I guess we can just say length of chars, right? And then we can check if chars of I is less than chars of I 1 is 1, right? So if that is the case, I think return false. So if the current one is bigger than the previous one, then that's false, right? So and then if all checks are done, then we can return true. All right, cool. So in this problem, the space complexity is constant because we're just going to be having 26 constant array, right? And then the time complexity is just O(n) because we're looping through the string once to count it, right? Okay. All right. Find email domain, okay? Okay, I guess it's pretty self-explanatory. We can just find the domain, right? All right, yeah, so given email address, just find the domain. The domain is like the part after the @ symbol, right? So that's called the domain. Okay, so I think the easiest solution would be just split it, right? So split by @ and then just choose the second part. So split it would be turning string into array, and then we pick the second element, right? So, oh, okay, it's not gonna be like that, huh? Okay, what is the correct answer to this though? Usual.com is the correct answer, which is that, I guess. Okay, so splitting it won't work. I think it's better to have just searching from the back until we hit the @ symbol, right? And then just return that essentially. So I in range of length of address -1, decrement by -1, and then goes until -1. And then if address of I is equal to @ then return address of I plus 1, then like that, return none. Okay, yeah, there we go. So we just basically go from the back and then see @ and then we just return this one. So that's the trick. And the time and space complexity of this would be O of n, right? Because we can search the entire string and then we can return the entire string. So that's why it's both O of n. Okay, build palindrome. Given a string, find the shortest possible string, which can be achieved by adding characters at the end of initial string to make it palindrome. Oh, okay. This might be pretty tricky. All right, so I guess so my initial thought is like essentially like you can give a palindrome string, right? Then you don't have to add anything, which means you can start from the middle and then check like if it's palindrome or not, and then if it's not, then keep going to the right, right, and then just check if it's a palindrome or not until you reach the end essentially. So basically, start from the middle and then keep checking the left and right indices to see if it's a palindrome. I think that might be the best solution out there. But also it depends on if it's odd or even count, right? So yeah, this is quite tricky. Yeah, I guess that is the only solution that I can have. Right. I guess we can do that. But this is actually like one of the harder problems in the code signal too. Not the hardest, definitely, but one of the harder ones for sure. Okay. I wonder how should I code this up? Because the palindrome center can be like, okay, so this can be the palindrome center, obviously, right? And then, but it can also be like this, like in between the characters. So we can be the character, or in between the character can be the palindrome center. So we have to account for that too. This is a really tedious problem, but I guess I would have to solve it anyways. Let's see. How should I start? Okay, so let's say I have this and then index that, but if I want to check this is the center, then okay. So I think having a function called is palindrome might be really useful. And then you have string and also index, and then also you have like the center or middle or whatever, right? Whatever you want to call it. I guess what's the good word to describe it? Center. Yeah, let's just call it center, I guess. So essentially, like this third argument is gonna be like, okay, is this character gonna be the center, or is the in between the characters gonna be the center, right? So that's it. So it is char center. Let's just call it like, I mean, is character center or not? Essentially, like, is this index character the center or not? So that's how we're gonna describe it. And then for okay, so you have to return actually the palindrome one. Damn, okay, that's troublesome. Okay. For I in range of length of st divided by 2, so we will start from the middle, essentially. And then, okay, so what if there's like 6, then, okay, so if it is 5, then it's the index is 2, right? So 1, 2, 1, 0, 1, 2. So it is correct, but in 6, it should start from the middle one. If it is 6. Okay. I guess 6 is 0, 1, 2, 3. So we will count this as the center. It is 6, but that's bad. Okay, let's just try and do this for now. And then what is the best way though? Okay, let's just do like if we don't have to pass an S because we already have it at the top. So is palindrome of I is char center true? Okay, let's assume that character is the center, then the return is what? This is really, really tedious. My brain is not functioning. Is palindrome of I false? Then what is it? Return something, okay. Is palindrome of that? Okay, let's try this then. Left is equal to index and right is equal to index. Okay, so let's assume these two start from the same thing, right? So that's like gonna be like is char center approach. Okay, let's just do like +1 then. And then if is char center, then we would have to start from the same thing. So right is equal to index. And then while right is less than length of st and left is greater than 0, whichever comes first, right? If st of left is not equal to st of right, then return false. Otherwise, decrement. Oh wait, this is this decrement, right is increment. Turn true. Okay, so that's how you would check the palindrome. Okay, I think this is good. And then essentially in here, what you want to do is if you start from the center, then let's just do that. And then I think what you can do is return st of until I +1 because it's including the character. And then plus st of I, and then reverse it essentially. Okay, so let's just look at this example, right? So let's assume this is the center, right? And then we want to return this portion and then this one reversed, right? So that's how you get this. But in other situation, the center is going to be like in between these two, right? Something like that. So what you want to do is return this and reverse that. So you want to return this until that, and then reverse the current one. Okay, yeah, I think this is correct. I would imagine. And then, yeah, I think this should work. And then I think if this loop ends without any palindrome, I think you can just return is that gonna be the case? I think no. I think this every time it should return a palindrome. I mean, if it goes to the end, anyways. Okay, some of them worked, some of them didn't. Let's just try this one. Okay, so you have already a palindrome, and is 4. Okay, so I think this should be -1, and then start from there. Let's just try that. Okay. I think there's like a edge case where if it's already a palindrome, right? So test 3 is like that. Test 4 is what? Okay, so it's not a palindrome. What's the console output? Okay, my return value is up. Okay, that's weird. That is extremely weird. Okay, so in this case, we have that, and then the console, no, my return value is, expected return is, oh, this is already a palindrome, right? So I think I can just eliminate that case by, so I have to start from this 0, 1, 2, right, 2, and then middle, right? Okay. If length of ST divided by 2 is equal to 0, then essentially I have to subtract 1, right? Like D is 0, D is equal to 1. Let's try that. Oh, it didn't work. So maybe I can do something like, is palindrome like an edge case or something? Is palindrome of length of ST divided by 2 minus 1 is char center is false, then return ST, I guess, something like that. Oh, what? D is not defined. Wait, okay, here. Okay, now it's everything working except this thing. What is the center in this case? A console. Why am I returning this one? This is so weird though. A, B, B, A. Okay, the center is this part, right? This thing. It should return the correct one. BA. So you have 4, which means 0, 1, 2. 2 center. 0, 1, 2. I guess this should be +1 then. Okay, yeah. I think there was a +1 error in here. Okay, cool. Let's just do that. Okay, cool. Yeah, this was a really bizarre problem. I don't like this, but I mean, essentially, you just invest enough time, you solve it, kind of thing. Yeah, the idea is just check the palindrome from the center every time, and then you'll be done with it. I think the complexity of this would be over n squared because you're looping through entire string and then checking the palindrome, right? So each iteration would take over n and then over n squared. The space complexity is like, you're returning the palindrome string, so it's over n too. So that's about it. Okay, go to the next question. Yeah, kind of bizarre problem. I mean, it was definitely on the harder side of things. Elections are in progress. Okay, so how are we doing on time? Okay. Yeah, let's try to finish this island and then we can finish this part. Elections are in progress. Given an array of numbers of votes given to each of the candidates so far, an integer k equal to the number of votes who haven't cast on there yet. Find the number of candidates who still have a chance to win the election, okay? Votes that and k is 3, so output should be 2, okay? I see. Okay. So basically, these are the list of votes, which means we have 4 candidates, right? And then if I add like all the 3 remaining votes to this person, then this will become 6, and that this person can win, right? And then if I add 3 here, then it's going to be 8. So this person already wins. So, but if I add it to here and here, then these 2 people cannot win because they're going to be equal, right? So there's just 2 people. Okay, so I think the trick is to just find the maximum vote, right? Maximum vote is max votes, and then just basically see if how many people, how many of them can beat the maximum, right? So for v in votes, if max vote v plus k is greater than the max vote, then count increased by 1, right? And then just return the count. So it's pretty, okay, straightforward. But okay, if there is 0, then return value is 1. Okay, I mean, yeah, okay, I guess that's the edge case. So if k is 0, then return 1, because I guess hopefully there's like one person that is winning. Maybe there are like multiple, maybe there can be like 5-5 or something like that, then no one wins. I'm not sure if there is a case like that, but we'll see. Okay, yeah, there we go. There is a case like that. So return max vote, and then if k is 0, and then if max votes dot count max vote is greater than 1, then return 0, otherwise return 1. Yeah, okay. I think this is fair. So essentially, like, if there are more than, right, I can just use count function to count number of max votes, right? And then if it's greater than 1, then we don't have anything. We don't have any candidates that can win, right? But if we have like k's exactly 1 count, right? The maximum is exactly 1 count, then just there's only 1 person that can win. So let's just do that. Cool. Yeah, I'm not sure if I can combine these 2 though. It's kind of difficult. Yeah, I think this is all I can do. I'm pretty sure there's another way, but I don't think I can do it at this time. So I think this is pretty good, the solution actually. So yeah, the time complexity of this would be O of n because we're just going to loop through once, right? And then this one is just looping through once, right? So it doesn't really matter on the time complexity wise. And space complexity, we don't have anything. So it's just O of 1. Okay, cool. All right, so the island is almost complete, I guess. Okay, so this is the last problem. A media access control address, MAC address. Okay, so this is like, it has it on every computer, every device that has a network card, right? Network interfaces, yeah. So physical network card, and then MAC address consists of like these characters 0 to 9, and then A to F because it's a hexadecimal structure, right? So, and then separated by hyphens. Input string, okay. Okay, output should be true, right? This one should be false. Okay, yeah. Gotcha. So yeah, let's just check the MAC addresses, right? So I think the first part would be parts is input string dot split. You have to split it by dash. Then if length of parts is not equal to like how many, 6, obviously then it's false, right? And then you can just loop through the parts and then analyze each parts. And then if length of part is not equal to 2, then it's also false, right? So it has to be like length of 2 on each part. And then we just check if it's like A to Z, not A to Z, sorry, A to F and 0 to 9, right? So if part Let's just do like if is hexadecimal part. If not, return false, and then we just do return true. Okay, and then we just create like a helper function that does check if it's hexadecimal. Oops. Okay, and then like that, and then we just loop through each character, and then what's the easiest way to do that? If C is digit, then continue. Okay, that's fine. And then if it's what should I do? Okay, I guess we can check the ASCII number too. So if C ORD of C minus ORD of capital A is greater than equal than 0, and ORD of C, ORD of F, capital F minus that is also greater than equal to 0, then continue, right? Otherwise, return false. And then you do return true at the end, because I think this is a good approach. So basically, if it's a digit, then it's fine. Just go on with it. And then if it's a between A and F, then we can check this one. Actually, I don't think I can. This is a bad approach. I think I can just combine this actually. So I can do like this. Like this. Oops. Yeah, this is much better. I can just do this. Nice. Okay, so let's just check that. Okay, cool. Nice. So yeah, obviously the time and space complexity of this would be O of n is the time complexity because we're looping through each of the string, right? And then space complexity, I don't think there is one. Or okay, I guess maybe there is. It's O of n because we're splitting into parts, right? So it's O of n. Both of them are O of n. Cool. So submit. Oh yeah, I've already submitted. Rainbow of clarity. Okay, so we only have 2 islands left, and then let's just leave that into the next part then, all right? This is part 4, I believe, right? So it's finished, and then yeah, I'll see you on the last part 5 then, all right? Catch you later.